Dear students, in the last class we have seen what is a matrix, what is the order of a matrix, different types of matrices like that square matrix, diagonal matrix, scalar matrix, identity matrix, what is a row matrix, column matrix. Today we will start with the equality of matrices. When two matrices can be equal. Matrices can be equal only if they are of the same order. First condition is they are of the same order, and the second condition is their corresponding elements are equal. You see, two matrices are equal, A and B are said to be equally found only if they are of the same order and the corresponding elements are equal. Here you can see if matrix A equal to Aij and B equal to B are equal only if A and B are of the same order and Aij equal to Bij for all I and j, means all the corresponding elements are. You see here, matrix minus 2, 3, 4, 5, 0, 7 is equal to matrix A, B, C, D, E, F only when this A equal to minus 2, B equal to 3, C equal to 4, D equal to 5, E equal to 0 and F equal to 7. Means we cannot say two matrices of, suppose here I am writing two matrices 2, 3, 4, minus 5. Another matrix 3, 2, minus 5, 4. Their elements are same. Elements are 2, 3, 4 and minus 5. But they are of the same order also. But the corresponding elements are not equal. You see? Therefore, these two matrices are not equal. They are of the same order. So, what two matrices are equal only when they are of the same order as well as their corresponding elements are equal. You see, such questions can be asked in 2 marks. Find the value of x, y and z when these two matrices are equal. You see, from the first equation what we can say, corresponding elements are equal means x plus y should be equal to 5. That another corresponding elements y equal to 2. These elements already z equal to minus 1 and 3 equal to 3, they are equal. It means y equal to 2 means, here if you are putting, we will get x equal to 3. Therefore, x equal to 3, y equal to 2 and z equal to minus 1. Such questions can be asked for 2 mark questions. Now, another thing I want to remind is, suppose a matrix has 6 elements. Suppose a matrix has 6 elements. What are the possible orders? One is this matrix. 6 elements means 6 minus 1, 2, 3, 4. How many elements are there? 1, 2, 3, 4, 5. Then 0. How many elements are there? What is the order of this matrix? 1 row and 6 column. There are 6 elements. Another we can say like this: minus 1, 2, 4, 5, 3, 0. How many elements are there? 6 elements are there. Therefore, what is the order of this matrix? 6 by 1. Another we can say matrix 3, 2, 4, minus 1, 0, 8. This is the order of 2 by 3. How many elements are there? 1, 2, 3, 4, 5, 6. Another one. Minus 1, 0, 4, 2, 5, 8. What is the order of this matrix? 3 by 2. Therefore, is any other possibility? No. If there are 6 elements, we have 1 6 by 1 by 6 matrix, 6 by 1 matrix, or 2 by 3 matrix, or 3 by 2 matrix. Suppose a matrix is having 5 elements. Which are the possible ways? In what way we can factorize 5? If there are 5 elements, that is 5 by 1 matrix or 1 by 5 matrix. These are the 2 ways. These are the 2 possible ways if there are 5 elements. Now, operations of matrices. We will see there are different operations. One is addition of matrices. Then we have scalar multiplication of matrices. Then we have the multiplication of matrices. Multiplication of matrices. These are the 3 operations that we are going to study. First we will see how we can add 2 matrices. Suppose A and B are 2 matrices of the same order. That also we have to remember. We can add 2 matrices only if they are of the same order. Then A plus B is the matrix obtained by adding the corresponding elements of A and B. You see here A equal to matrix Aij is of order m by n. Then B is another matrix, matrix Bij, order m by n. Then A plus B is the matrix of the same order obtained by adding the corresponding elements of A and this is the answer of A plus B. We have one example. Suppose A is the matrix minus 1, 3, 4, 2, 5, minus 7 and B is the matrix 2, 0, 5, 8, 1, 6. Then A plus B, they are of the same order. They are of the same order, therefore we can add them. How we can get A plus B? By adding the corresponding elements. Minus 1 plus 2, 3 plus 0, 4 plus 5, 2 plus 8, 5 plus 1 and minus 7 plus 6. This is the answer. Therefore, to get the sum of two matrices, we simply add the corresponding elements of the two matrices provided they are of the same order. Suppose one matrix is like this. And another matrix minus 1, 3, 4, 2, 5, 6. Here we cannot add these two matrices. Why we can't add these two matrices? Since they are of different orders. We cannot find the corresponding elements for each elements here. Therefore, it is very important that if two matrices are to be added, they should be of the same order. Next. Now, what are the properties of matrix addition? Whatever properties in number addition we are having, that will be followed here also. Whatever properties we are having in number addition, that properties all are applicable in matrix addition also. The first one is matrix addition is commutative. Commutative means, suppose A is the matrix minus 1, 2, 3, 4 and B is the matrix 0, 5, 3, 8. Then what is A plus B? A plus B is the matrix obtained by adding the corresponding elements. Minus 1 plus 0, minus 1, 2 plus 5, 7, 3 plus 3, 6, 4 plus 8, 12. Then what is B plus A? B plus A is equal to 0 plus minus 1, that is minus 1 only, 5 plus 2, 7, 3 plus 3, 6, 8 plus 4, 12. You see, these two matrices are equal. Therefore, matrix addition is commutative. Next property, suppose we have three matrices A, B and C. Just you can verify also we are by putting in three matrices. If A, B and C are three matrices, then A plus B plus C equal to A plus B plus C. Suppose we are to add three matrices, then first we add B plus C, then adding A, it will be same as A. First you find A plus B, then plus C, as the number addition is, the addition of numbers is commutative in the same way. Matrix addition is also associative. A plus B plus C equal to A plus B plus C. Next one. Next property is existence of additive identity. Suppose A is the matrix minus 1, 2, 0, 4. Then B is the 0 matrix 0, 0, 0, 0. I am just reminding you, 0 matrix means all the elements are zeros. Then if you are adding this A plus 0, A plus the 0 matrix minus 1, 2, 0, 4. That is same as A only. Therefore, if we add 0 matrix to any matrix of the same order, then we will get the same matrix as the answer. Therefore, 0 is the additive identity. We call 0 as the 0 matrix as the additive identity of the matrix A. Next, if you are finding any matrix, then if you are adding the corresponding minus of that matrix, negative of that matrix, we will get the 0 matrix. Suppose A is the matrix, then 0, minus 3, 4, 8. Then minus A as 0, 3, minus 4, minus 8. Then what is their sum? A plus minus A. What is that? 0, 0, again 0, 0. That is the 0 matrix. Therefore, for every matrix A, there will be another matrix such that their sum we will get a 0. For every matrix A, there will be another matrix minus A, or we can call B also, such that their sum is 0. Therefore, that matrix is the additive inverse of that matrix. You know that in number theory, what is the additive inverse of 7? That is minus 7. Why? 7 plus minus 7 is 0. What is the additive identity of minus 1? This plus 1. Why? Minus 1 plus 1, we will get the additive identity. In the same way, if we add minus of a matrix to any matrix, then we will get the 0 matrix as the answer. Therefore, there is the existence of additive inverse. For any matrix, we can find that. Next is scalar multiplication. Suppose for any matrix A and a scalar C, the scalar product Cm is to multiply each element of A by the value C. That is example. If here an example is given, if A is the matrix 1, 2, 3, 4, 5, 6, then 2A is obtained by multiplying every element of this A by 2. 2, 4, 6, 8, 10, 12. Therefore, scalar multiplication means suppose there is a matrix. Then 5A means what is 5A? Multiplying every element by 5. Minus 5, 10, 20, 15, 20 and 35. This is 5A. Therefore, if we multiply every element of the given matrix by a scalar number, then we will get the scalar multiple of that matrix. Now some properties are there. We will see the properties of scalar multiplication also. That is, we can just K into A plus B. If A and B are two matrices and K is scalar, then K into A plus B is K into A plus K into B. First you find the sum, then multiply. It will be same as first you multiply and taking the sums. The next one is, if K1 and K2 are two scalars, then K1 plus K2 into A is same as K1A plus K2A. That is another property. These are the properties of scalar multiplication. Now, in the next session, we will be seeing how we can multiply the matrices. Okay, thank you.